Lesson 5-10 Practice Cross Sections and Volume. Question 1. This vase has a base of capital B square inches and a height of H square inches. Which statement is true? I got this wrong before because that is the wrong picture. I looked it up and this is the picture. So you can see the base is large. So if you take the area of the base times the height, like it was a cylinder, you see it has a neck. So its volume is less than the area of the base times the height, cubic inches, because this has a neck. It's skinnier than a cylinder. Question 2. Noah is deciding which of two juice containers he should buy. One container is in the shape of a cylinder with radius 3.5 centimeters and height 12.5 centimeters. The second container is in the shape of a rectangular prism. The prism also has a height 12.5 centimeters. Its length is 6.4 centimeters and its width is 4 centimeters. Complete the following about the volumes of these containers. All right, so the first one was a cylinder, and a cylinder is pi r squared. Pi is pi. And it said the radius was 3.5 and the height was 12.5. So we take 3.5 for the radius and the height was 12.5. You can see its so you take the area of the circle times the height, and its volume is about 481. The second container, its length is 6.4, its width is 4. Length times width, the area of the rectangle, times the same height, 12.5. You can see the first volume is greater, the cylinder. The cylinder, cylindrical juice container has the larger volume. Question 3. This question has two parts. First answer part A, then answer part B. Part A. Zigzag crystal vase has a height of 10 inches. The cross sections parallel to the base are always rectangles that are 6 inches wide by 3 inches long. If we assume the crystal itself has no thickness, what would be the volume of the base? Well, it's 6 by 3 rectangle, that's 18. 6 by 3 rectangle, that's 18. And times, what was this height? Times the height of 10. Height of 10. That would give us 180. If we assume the crystal has no thickness, what would be the volume of the base? That would be 180 cubic inches. The crystal is actually half an inch on each of the sides and on the bottom. Which explanation correctly approximates how much space is contained within the base? So if it has a half inch on the bottom, that means its height would be 9.5. And each of these, if it loses a half inch on each side, the length would be a full inch, which would be 5, and the width would be a full inch. It loses a half inch on each side, so that would be 2. 5 times 2 times 95, 9.5 is 95 cubic inches. If the glass takes up 1/2 inch all the way around the inside of the vase, the interior base measures 5 inches by 2 inches, so it has an area of 10 square inches. The interior height of the base is 9.5 inches. Multiply the area of the base and the height, we get 9.5 times 10 equals 95. Question 4. Drag the solids into the bins for which the formula the volume equals the area of the base times the height applies, and for which volume equals the area of the base times the height does not apply. To find the volume, it has to have two bases. So a cone has an apex and a base of a circle. So it does not have two bases. A cylinder has two circle bases. A rectangular prism has two rectangle bases, and a square pyramid has a square for a base and an apex. It only has one base. Question 5. This question has two parts. First answer part A, then answer part B. All right. Each small square represents 1 square centimeter. Which of the following is the solid formed by rotating this two-dimensional figure around the vertical axis shown? When you rotate it around the vertical axis, it'll be sitting on its base, so on one of its two bases. So it'll have a 1-inch radius hole, and the distance then it would have an additional 5-inch radius and a 2-inch height. One radius hole, 5-inch additional radius, and a two for a height, and it's sitting on its base. What is the volume of this solid? Express your answer in terms of pi. All right, so we'll be using the pi r squared times height. The radius would be, if you look at the figure, the radius would be this 5 plus 1. The radius would be 5 or 6. Pi r squared is pi 6 squared. And then the height we know is 2. We're going to subtract from that the whole, so pi pi, 1-inch radius, pi r squared, and it has the same height of 2. They want an exact answer in terms of pi, so 6 squared is 36 times 2 is 72 pi, minus, and then 1 squared is 1 times 2 is 2 pi, and 72 pi minus 2 pi is 70 pi. We could copy and paste our answer, or we could type in 70 pi. No, not pi. 70 pi symbol. Question 6. A solid has volume 2 cubic units and surface area 10 square units. The solid is dilated and the image has volume 128 cubic units. What is the surface area of the image? All right, they give us a volume beginning at 2 and it's dilated to 128. Volume is cubed, so we're going to find the cube root, CBRT, the cube root of 128 divided by 2. 128 divided by 2. You can see it's dilated by a scale factor of 4. So they want to know if it has a surface area of 10 and it's dilated, what would it be? So surface area squared, the inverse of that is square root, SQRT, and we're going to take x, some number we don't know, what we're trying to find, and divide that by the original surface area, which was 10, and it's going to have a scale factor of 4. To solve this, we square both sides. We get x divided by 10 equals, and if we square 4, 4 squared is 16. We multiply both sides by 10, we get x equals 160. Question 7. A solid with surface area 50 square units is dilated by a scale factor of K to obtain a solid with a surface area 200 square units. Find the value of K. As we said, area is squared, so we're going to use square root. SQRT, and it's the square root of 200 divided by 50. And you can see the scale factor is 2. Question 8. Select all figures for which all cross-sections taken at a particular orientation are congruent. A cone, all of its cross-sections would be circles, but they get smaller as you go up to the apex. So a cylinder, all of its cross-sections are congruent circles. So no matter where you slice it, the circle is going to be congruent, whether it's on the top or bottom. A rectangular prism also has equal congruent rectangle cross section. So wherever you slice it, and finally, a square pyramid, it would have square cross sections, but they would get smaller as you go up to the apex.